Welcome to everyone today. We are so delighted to have you here. My name is Sara Kobilka, and this is the WaterWise Visual Science Communications Seminar. This is something that the WaterWise team from the University of Arizona has been running for 3 years now, I believe. It's been such a wonderful opportunity for students who are part of our program to think more broadly about visual science communication. I'm going to take just a short minute or so to tell you a little bit about what the WaterWise team does. We are what you call a VIP or have a VIP model, which is a vertically integrated project. This is actually an international model for doing projects at many universities, and it integrates faculty members. My colleague, Dr. Laura Condon from the hydrology department is our lead, with grad students and undergraduates. Many VIPs are doing research, but there are also ones that are coming from the field of engineering. And ours is kind of unique in that we're more like the engineering folks, where we get clients. In this case, we are working with clients who are broadcast meteorologists, and we create scientifically accurate graphical answers to water questions that impact all of our lives. So obviously in Arizona, water matters a lot because of the extreme heat and the desert location. I have on the screen right now a screenshot from a Facebook post by one of our clients. Amber Sullins is the chief meteorologist at ABC 15. In this Facebook post, she's talking about how monsoon 2023 has officially begun. And it says, in the months ahead, one of our biggest concerns will be flash flooding, especially near and downstream of our wildfire burn scars. It goes on to talk about those burn scars in the Flagstaff area. There's an image of Amber standing in front of a graphic that has a label Wildfire Burn Scar Flooding. And she is talking. And what I'm going to do now is to actually jump to the Facebook post that I took the screenshot of. And you'll be able to hear what she's talking about as she stands in front of the animation that we created. And after it's over, I will also explain what is being displayed on a green screen behind her. So I'll jump and slightly adjust my cropping so that you can see this. It was very exciting. This graphic that we made for Amber and the team at ABC 15 was actually part of their monsoon special in 2023 and 2024, and they did actually receive an award for that coverage.
As rain comes down in our Arizona forest, much of it normally gets absorbed by our tree canopy and the ground. But during wildfires, our land gets scorched, creating a hard crust on the surface that actually repels water. So when monsoon storms hit, the water will not soak in like it used to. Instead, it runs off of the burn scars just like it would on pavement, which leads to flash flooding and debris flows happening much faster and with much less rain. And it's not just in the areas near the burn scar itself. That flow, it travels all the way down slope, picking up more mud and debris along the way, impacting communities miles away from where the actual wildfire or even storm occurred.
In the beginning part, Amber is standing in front of a scene that is like a mountainside that has trees in it. On the left-hand side of the screen, in the moment that I've went back to in our timeline, the forest looks normal. There's some grass and shrubs. On the right-hand side of the screen, we're showing what happens when there is a fire. So it's a very desolate landscape. There's some branches that have been knocked down. There are no leaves on the trees or pine needles. And we do a cutout that's showing partway through what happens underground. And we have arrows representing how the water normally would go into the ground, getting soaked in by the soil. But then when you have that wildfire, it's cooking the top layer. And so it almost makes it like concrete. And then we have significantly more arrows above the ground and showing that water is just running off at a fast rate. And then, as she mentioned, it picks up lots of things. And then we transition to a video that was created using Google Earth. And so in the Google Earth video, we're flying up above a mountain and we see a blue line representing the pathway that the water would be taking down the mountain. And a burn scar is highlighted in red near the mountain top. And then that blue line extends all the way down to the base of the mountain, which is where the flooding might happen in a town. And you can't even see the burn scar, but you need to be aware that you could experience flooding. So this is one of the things that our team has created. We also create alt text for the still versions of these animations. So we do regularly talk a lot about accessibility from the perspective of the alt text, thinking about color contrast because TV stations have requirements regarding contrast. We talk about using plain language to explain things. So accessibility is deeply ingrained in what our team does. And we're really excited to continue that conversation today. So we've had two speakers so far. We talked about from data table to 3D visualization, the sap flow in cacao trees, which was in Biosphere 2, which is a research facility on the University of Arizona campus. Then 2 weeks ago, our title of our talk was Slowing Down to See More Using the Arts to Improve Scientific Data Literacy. Today, it's InSightFull, the ripple effect of math accessibility updates in Microsoft 365. And 2 weeks from today, we will have our final speakers who will be discussing communicating complex data through 3D representations, examples of planetarium visualizations, and data physicalizations. For today, we have three speakers. Ailee Dixon, Peter Wu, and Sara Shunkwiler are in the slide that is on the screen right now. There's smiling pictures of the three of them on the right-hand side. I'm going to let them tell you a little bit more about themselves because they've got a whole great slide already pre-planned to do that. So I'm going to, at this point in time, stop my share. They will also talk a little bit more about our effort to make this particular webinar, or actually all of our webinars, as accessible as possible. So sharing some information for how you can actively participate in today's event. We're going to do a Q&A at the very end. Sara.
Sounds great. Thanks, Sarah. Spelled the same. You can turn on captions. I just hid them on our screen, but if you want to save the transcript, you can also click on that down there with your captions and save the transcript. Ailee's dog is with us today because Ailee is blind, and since screen readers don't necessarily play well with Zoom, so we're presenting together from my office. But because Zoom is not all that accessible, I put their email address on the screen so that you can actually email them access@zoom.us and let them know that cart captioning is important, getting that installed quickly in meetings is important, and accurate transcripts matter.
Yes.
I guess that's it for that slide. And as Sarah introduced us, Sara Shunkwiler. I'm an engineer, instructional designer at Johns Hopkins. I have quite a wardrobe of disability advocacy t-shirts. Today's is math related and says, be like subtraction and make a difference. Behind me on my wall is my Disability is Human flag from Stephanie Cawthon's book by the same name. And there's a quote above my head that says, beauty is the first test. There is no permanent place in the world for ugly mathematics. No ugly math being really big so that our tech team can see it in workshops. And inaccessible math is definitely not beautiful in my world. So I guess we can go on to the next slide and I'll talk really quickly about how this partnership got started. I tend to talk fast, so I do apologize for that. We also have a lot to cover today. Peter and I met on LinkedIn because, as I often say, I was low on spoons, which means I am disabled. That's pinned on my LinkedIn profile too. I was tired and I had a lot of math equations in PowerPoint that were not getting read correctly by screen readers. So I reached out to Microsoft and tagged Clint Covington on LinkedIn, and Peter responded to me about 3 minutes later, I think, on a Sunday afternoon. And for me, the frustration was having to buy external tech tools to create accessible math equations. We have a new article in our Hopkins Engineering magazine that opens with, we met over 1,000 inaccessible equations, which is true. That was Brian Bauer and I, one of my space systems faculty who's been really amazing at supporting me through a pretty rough patch with my own disability and going wherever I ask on presenting about math. Now, our group at Hopkins Engineering has been meeting with Peter's group at Microsoft and the DAISY consortium of screen reader users. And so that's how this all got started. I'm going to turn it over to Peter to introduce himself.
Hi, thank you. Yes, I'm Peter Wu from Microsoft. I've been working there over 30 years, and the past decade or so, I've been focused on the accessibility PowerPoint. And as Sara mentioned, she reached out on LinkedIn, and I learned that the accessibility of math in PowerPoint, while there's parts of it there, it really wasn't as good as it should be. And I learned a little bit more about what they're doing and how we could make it better. And I had this connection to Johns Hopkins, where Sara is at. I went to summer camp there in 1984 at the age of 11. So there I am in the class.
I love it. And you also went to Ohio State too.
I also went to Ohio State University for a summer camp in math there as well. Yeah.
The Ohio State University. Jeff Kwan, who's a math professor at Ohio State, is working with us and actually hired Ailee to work on some math equations.
Ailee Dixon. I am a disability and STEM equity advocate, and I also am the
Youngest.
youngest commissioner on the Equity and Inclusion Commission of Frederick County, which I'm really excited about. And also today is my birthday, so I'm also very excited about that. There's nothing else I prefer to do than advocate on my birthday. And at the age of 20, I became blind. I always joke, I get asked a lot when I do interviews and stuff like that. They ask me, was this a progressive disease or did you know you were going to become blind? And I always make the joke, I didn't see blindness coming. I didn't know I would become blind. So I was actually in nursing school. I wanted to be a nurse practitioner with sign language interpreting. Obviously, I can't really do sign language that much anymore. I have a lot of deaf and hard of hearing friends, but communicating is a little bit more difficult. But I was told by my professors once I became blind that even if I managed to get my degree, which they didn't think I would be able to, that I'd be seen as a liability, which everybody at Johns Hopkins, every time I present, they are so upset on my behalf that I was told that, and they basically very much encouraged me to drop out, and also mainly because STEM is just not very accessible even to screen readers. When I was doing stuff for Jeffrey Kahn, who helped create Taylor Swift bot and was running math equations through my screen reader, I used Fusion to get around my computer. It thought it was like a Slavic language. It didn't even read it as a math symbol. So higher math like calculus and algebra, it's just not there yet. We are slowly getting there. It's better than what it was 30 years ago, but we sure have a long way. And I'm very much a big advocate. It can be done, it just hasn't been done yet. So them saying that it can't be made accessible, it can, you're just not willing to. So if we raise the awareness and get more people involved to care about making it accessible, then nobody will be told that. I want more disabled individuals to be seen as leaders and not liabilities. That's what they should have encouraged me, and that's what I want to encourage others as well.
Thank you. And the picture in the middle here, when Ailee and I actually met in ninth grade, she was.
I was in ninth grade. I was paralyzed.
She was paralyzed. And the picture on the left is a collage of the two of us getting the chance to go back to our school board where I was her teacher and she was my student. She was pushed out without her high school degree because, yeah. So we got a chance to go back and let me talk as a teacher and her talk as a student about that. The picture in the middle is her learning.
Just stand and walk again.
Yeah.
That was a journey.
All right, I guess we'll talk about what does accessible math mean to you. I know adding that in the chat is not the most accessible way to do things, but that is something we're curious about. On the next slide, there's a quote that I really like. I use this a lot from Jonathan Kaufman. It says, "Disability is the essence of diversity by definition. It runs across race, ethnicity, gender, socioeconomics, culture, and the most important thing, it's the only minority group anyone can join at any time, which makes it unique." From An Inclusive Future of Work, Source America 2020. And I think you're a good example of that. You weren't expecting to become blind, just woke up.
literally woke up blind.
Right.
I went to bed able to see, and I woke up and it was like looking through two straws. And with time, it's like I only have a light perception at this point. I have no acuity, which is like your clarity. But a lot of times I'll be talking with somebody, they have no idea. If I put my white tipped cane away, which I often do, they have no idea I'm blind. And I'm just like, did you really like how media and TV portrays blind people is we're feeling faces and we have the big goggles and we have our hands in front of us, and it's like that's really just not a good depiction of what blindness is, or that you can look in their eyes. And that's I wish in a way that's how it was, but it would make it easier for people to understand. But I look pretty able-bodied, and that's both good and bad things.
Actually, I think you have some stats on the next slide about blindness and mobility aids.
Yeah, 87% of blind individuals don't use a mobility aid, and only five use a guide dog, and I think it's 2 to 8% use a white-tipped cane. So you can't really assume somebody isn't blind, because blindness is a spectrum, just like anything in life. Even when I had my acuity, but I had no peripheral vision, but I was looking through two straws, I was legally blind. I was considered blind and could not drive at that point, but I could still see only if I was looking directly at something. Now it's not that way, and now I can see light perception, so I can see sparkle. I have a bedazzled white tipped cane, okay? So it's like I can see sparkle real well. Even my sunglasses are sparkly, so I can see them and grab them. So yeah, you can't just be like, oh, that person uses a mobility aid and they can see, because that's not the case.
I think that makes a difference in our classes too, because we have a lot of faculty who say we don't have any blind or low vision users. You just don't know that.
Not only do you know that, but if things aren't accessible, why do you think you don't have any blind or visually impaired students? Because they're going to go where they're already being accessible, because not every disabled individual wants to be an advocate. The disabled minority is not a monolith. It is very diverse, and not everybody wants to be a proud advocate. Some people just want to be and exist and go through life. And as a disabled individual, it's very difficult to do that. Are we at the
As I said to you one time, Ailee, you're a leak. We talk about the leaky STEM pipeline, and I'm like, I can say this.
I love you.
You're a leak in the STEM pipeline. Literally, we don't have that many students in our classes because they haven't made it through to higher education. I think we have one more quick stat on blindness, and then I'll talk a little bit about disability in general.
Okay. So are we at the 2023 slide?
Yeah.
Okay.
Yeah.
Sorry. Not being able to see sometimes is difficult doing this. 7 million Americans are estimated to be blind or visually impaired, and that number is projected to double by 2050 due to aging of population and the prevalence of disease, which is why I say not only as individuals, but as a society, we are not prepared for that to happen. So that's why I'm a big advocate and currently trying to help pass a bill to make all pedestrian signals accessible pedestrian signals, especially with electric cars being more manufactured. It's not safe for me to cross the street because I can't hear them. They're silent. And how a blind person crosses the street is we listen to the flow of traffic. If I can't hear them, then I need a pedestrian signal to beep at me when I can cross the street to safely cross. So it's no longer an individual issue, it's a community issue.
Exactly. And if you've seen some of my talks before, we talk a lot about disabilities in STEM, but just really quickly, disabled STEM professionals in the workforce are underrepresented in post-secondary degrees awarded, and we have higher unemployment and underemployment rates. And I say we as a disabled engineer who was pushed out of that career because of my disability. And self-identification, 9% of workers in the general population self-identify as disabled, while only 3% in the STEM workforce, because of the stigma of disclosure bias in STEM. I didn't disclose my disability for 25 years. It was only in the last couple years that my engineering faculty encouraged me to publicly disclose, just to be a role model for our students, because a lot of disabled students in higher ed, or who aren't in higher ed.
I knew you were gonna point.
Okay, yeah, the next quote says, successful people with disabilities can pave the way for students with disabilities who are ready to take on the challenges in pursuit of STEM majors and careers. But how are we portrayed in society? We had been doing a talk on AI, so how are we portrayed by AI? I'm going to turn it over to Peter in just a sec, but we have a slide here. The Astro Access team was also started at the Ohio State University. And this is part of the crew from 2024. One of our students, one of our alums, Apurva Varia, is circled to the left. He was a deaf astronaut at NASA, unfortunately passed away unexpectedly that year too. But I circled Mona Mankara, who is a blind astronaut on that team for Ailee's benefit. And we have a lot of extra resources in our slides because we have too much to cover. There's another picture of Apurva and Mona arm in arm in zero gravity later. This is a hyperlink underneath here if you get our slides. The Houghton Mars project, it's nice to have the astronauts themselves introduce why accessibility is important. We have Ailee here with us today, but that's a good clip from them also.
Did you say their quote?
Oh, yeah. Ailee said, did you say their quote? If we can make space accessible, we can make any space accessible. I really like that.
I do too.
So some of the things that get overlooked in STEM a lot from an accessibility perspective, we do a lot of talk specifically on math. So we talk about the visual, auditory, and symbolic components of math as a language. We have a couple longer talks on math if you have faculty or other people who want to learn more about the why of math and how to teach math accessibly, like in what we say, to make sure it gets captured in transcripts and captions and that. But visual clues aren't available to Ailee. She can't see an equation and quickly figure out how big it is, how long, what's the hierarchy in there, are there fractions, numerators, denominators, exponents. If you're only hearing it and have to make a picture in your mind, it's very difficult.
For the least.
Yeah. Visual only materials and images, it says aren't read by screen readers, but we had an example recently where we were at the Frederick County Commission meeting.
Yes.
And everything was printed. So none of it was accessible. One of the things Peter has worked on for us is the auditory accuracy of equations that are read, and then symbolic accuracy, just to make things sure that things are displaying correctly in the PowerPoint and Word. But on this slide, we just wanted to make the point about complex alt text. This is a challenge. I think we all are trying to figure out how much information is too much, how much information is not enough. This was actually a picture from our magazine article in Hopkins magazine about Ailee. It was talking about using AI to add alt text in PowerPoint, but the biggest point here is please go make sure it's correct.
Please, I beg you.
Text in images is something we don't think about isn't read for screen reader users. So this top picture is from the Hubble Space Telescope, and the white text, which nobody can read, it's very small, was actually from NASA's alt text description, but it's part of this image and it's not going to get read. The image on the bottom is a screenshot from one of my classes where the faculty member had taken a picture of a textbook and pasted it on the slide, but that's not going to get read to students either. So we ended up having to recreate all of that content accessibly. Annotations are another thing that don't get read, and we have a lot of faculty that like to write on slides. And so adding alt text to the slide notes, adding it to the image itself, color contrast came up. Obviously, legibility can be a problem. We've talked a lot, Peter and I have, about using like AI to create math out of those images that you can then paste into a slide or a Word doc. And I think we're working on that as well. The next point we just wanted to make really quickly is reading order. A lot of people may not think about this, but for Ailee, as she's going through a slide or a document or something, she can jump from heading to heading or have a slide read to her, but is it in garbage order or does it actually make sense? One thing I made a note is that you have to be a little bit careful about changing the reading order if you end up covering up content, which is why we try not to overlap content. But at the same time, your reading order may not be accurate as it's flagged. I think we have an example maybe on the next slide or the one after that where this reading order might be flagged as incorrect, but it actually is correct to me, the user, because this is the order in which I want things to be read. This is the accessibility checker and the reading order pane. So a point we wanted to make is that reads top to bottom. We have a picture on the next slide that reads bottom to top because this is the selection pane. And I mention this because I've made this mistake of going in and thinking that this reads top down, and I rearranged everything on the slide only to make it all backwards. Don't do that. This also has a picture of a hidden slide title so that if Eileen's jumping through slides, she can go from title to title. But if you repeat the same title on 5 slides, then she doesn't know which slide she's on. So this is a hidden slide title, and this is our leaky stem pipeline slide that we use a lot. So we just used it as an example also. The complex alt text is in the slide notes, so she could access it there. And
one thing I want to say real quick, and when it comes to accessibility, I understand some of this is a pain and it's extra steps and it's already hard work that you've already put into creating the presentation, but then adding all the accessibility. But also, you got to think of it from the perspective of the person that is not being included because you didn't want to put in the work or it was too much effort for you. I totally understand sometimes when I post a picture on Instagram, I don't want to add the alt text because it can be an absolute pain. But I also know that not only would I benefit, but individuals like me would benefit just from some small action. So to me, it's 100% worth doing it to be able to include someone because I think we all know what it's like to be excluded and it's not a good feeling, especially when it could feel like you are being targeted. So just know that I know it's difficult. It is not easy, but once you get it down, it's like a flow. Would you say so? I feel that, but I'm also blind, so a little different.
yeah, we're going to turn this over to Peter, but that's something that he said to me yesterday too, that this is what they're trying to do is make it easier to make your products accessible. So sorry, Peter, we took up a lot of your time.
And
No
Sarah, we
worries.
had one question in the chat. Dr. Maddie Kloss says, I've heard that PDFs can be a nightmare when considering reading order. Is this true from your experience too? And if so, how do you suggest getting around this? And you may talk about this later, but is reading order the problem with PDFs or is it everything about PDFs?
Yeah, right.
It's everything the problem with PDFs. PDFs, it's really hard to even have like alt text on a PDF. So a lot of times I have to fill out forms. They send it to me and I'm like, I have no idea what this says. Like my screen reader will not read this PDF. And it's most of them. It's not some, it is the majority. I think I've only ever come up with like 2 or 3 that were accessible. Don't know how they did it. I don't usually make PDFs, so I cannot speak on that. But yeah, the reading order, even on the ones that I have been all over the place. But maybe Peter can speak more on that as well.
It can be challenging, especially when you have a complex layout of objects like on a PowerPoint slide. What we recommend is that you use the reading order pane in PowerPoint to set the reading order of the content in the way that makes sense and the way you want people to read the content. And if you do that and then you do save or export as PDF, then that reading order that you've set in PowerPoint carries over to the PDF as well, so that it'll make sense there when you're viewing it in the PDF viewer. So use the reading order pane in PowerPoint, then you don't have to be fixing up your PDF later. Great. So I will go on and dive into making math accessible in PowerPoint and Word and other applications. That's something that we worked to improve in the past year, and just give you some guidance about what you should think about when you are creating content to make sure that everybody is able to access that content. So in this slide, we have 2 equations, one on the left, one on the right. The one on the left, I was able to click and put the insertion point into the math and the equation ribbon appeared. And the second one, I wasn't able to do that. It's actually just a picture of math. And so as much as possible to get the best experience in terms of accessibility, try to stick with the native Office math, the kind on the left, and avoid taking screenshots of math or using add-ins to embed objects of math, which is a little more difficult for people to work with. And I'll show you that you can easily create math in the native format in PowerPoint by using the equation ribbon and just use the graphical interface. It's pretty straightforward to find the symbols there and find the structures and fill in the placeholders. It's pretty intuitive to do that process. And then you can construct your equation in that way. But as you can see, it does take a little bit of time, right? So there are some shorthand ways of doing it. Here's a way where you can do it entirely with the keyboard without having to navigate that graphical user interface, which is great for people using a screen reader. You can type it with some short codes with a backslash and some parentheses to enclose the parts of your expression, and then it'll automatically convert to the professionally built up math. You compose it in a format called Unicode math. And once you learn to be proficient with that, you can type the equation much faster that way. And another way you can go about doing it is if you're in the university and research area and you live and breathe LaTeX, and that's the format that you prefer to use, you can also type your equations in LaTeX format and then convert them to the professional format. So in this case, I'm typing it out and then I click the LaTeX to math button to convert it to the native math. So there's several different ways to insert the
Peter,
math.
we have a quick question, and they're wondering whether this is also available for chemistry.
To some degree, yeah, we're going to improve that some, but you can use mathematical structures like the arrow symbols and the subscripts and superscripts to compose chemical formulas. The LaTeX support right now does not include the chemistry packages, but that's something we're looking to expand on in the future. So stay tuned.
How about the International Phonetic Alphabet?
Let me get back to you on that. I don't think we support that, but we have a large set of symbols, mathematical symbols, including Greek letters and script calligraphy letters and so forth that are commonly used in mathematical notation. Really good. I'll show you another option, which is that you can handwrite your math. You can do that on paper to take a picture of and all. But in this case, I'm just doing it with digital ink directly on the slide. You can select that digital ink and do ink to math. So that's another option for inserting this native math. And going back to that first slide that I showed you, the equation on the right is actually this embedded type of equation editor object that may have been created in a very old version of PowerPoint from like 15 years ago, or may have been created by the math type add-in. We have a feature there to convert that equation object into native Office math, the type that you can place the insertion point in. So that's what I've done there. There's a command to do that in bulk for all the equations in the presentation as well. And you can do that in Word as well. So in case you have those types of objects in your old documents and presentations, I recommend converting them to the native Office math. This is an example where you can check the checkbox so that it does it for all equations in the presentation. So another thing that is pretty recent, which is an exciting development with accessible math in Word and PowerPoint, is that there's a lot of math in MathML format on the web and in EPUBs as well. Here's an example where I'm using Copilot and I've asked a question about math, and the response includes this nicely formatted math that I can simply drag to select the content and do copy, and then go into Word or PowerPoint and paste. And when I do that, all the math is preserved and it's in the native format. You can edit it and it's accessible. And so this is really fantastic because there's a lot of this kind of content out on the web on pages like Wikipedia and ChatGPT and Copilot and so forth. And here's the example with Wikipedia. So just copy it and then paste in PowerPoint. So a lot of easy ways to get native math in Word and PowerPoint. If the web page uses MathJax, which is a popular way of embedding math into web pages, unfortunately, that technique that I just showed you doesn't work, but you can copy the equations individually by going into each equation and getting the MathML code for it and then pasting it into Word or PowerPoint. And you might need to do paste keep text only in order to get it to come in as the native professionally formatted math. What I'm going to do is show you that once you've been using native math in Word and PowerPoint, you can read that with the screen reader. And so that's the whole point of using this format, is that it has all that rich semantics and structure, and the screen reader can then read it in a way that you can understand what the hierarchy is and what all the operators are and so forth. You know what's inside the radical versus outside the radical. So here's an example of reading the equation in PowerPoint slideshow with the free screen reader that comes with Windows called Narrator. And you can even do it a unit at a time, so in case the equation is large and it's hard to understand.
Open paren x plus a, close paren to the n, text box. Equals. Sum from k equals 0 to n of, open paren n, atop, k, close paren, x to the k, a to the, n minus k n superscript, n summation. Characters. Start lower limit k, equals, 0, and lower limit. Start upper limit n, and upper limit. Start sum and open paren. Start stack. Start upper element n, and upper element. Start lower element k, and lower element, close paren.
Yeah, so that shows that you can read it like word by word, or even drill down into character by character, so that you can study the equation and know what all the structures are and understand it that way. So that's what you get if you use the native Office math.
We have a question. Doug is wondering, is this done in Narrator like NVDA does with arrow keys to zoom in on math?
The experience with Narrator is not yet like that, where it's hierarchical, but that is something we're working on currently. Yeah, with NVDA and JAWS, you can use like down arrow and up arrow to navigate the hierarchy. You can do that in Word currently. Unfortunately, it's not available in PowerPoint yet, but that's also something we're working on as well. So stay tuned. There's certain combinations that work, and we can give you some guidance on what are the best options to use for each app in each scenario. Great question. Thanks. This is an example of editing an equation with the narrator on in PowerPoint, and I'm going to use the right arrow key to move the insertion point around in the equation, and it's going to read out the character that's to the right of the insertion point. But in addition to that, it's going to give me context information about which structure I'm in. So it's very clear where the insertion point is, and if I start typing, where that new content is going to get inserted.
Start equation x equals fraction. Start numerator minus b plus or minus. Start square root. Start root b squared. Start base b and base. Start superscript 2 and superscript minus.
So I'm very confident about whether I'm in the numerator or the denominator, if I'm inside the root or outside the root. All that context information helps me know where I am to be able to edit this equation. And then another thing I'm going to show you is when you are presenting remotely with Teams, you can use PowerPoint Live to share your presentation rather than screen sharing. And that's a really magical experience. The participants can read the contents of the slide with the screen reader. And if it has math, they can even read the equations in the slide. So I'll show you what that looks like for a participant in a Teams meeting with PowerPoint Live.
Files, Math, our universal language. Final Brown Excel Share button. Slide 1 maps menu item. Slide navigator group. If puppet liquor grid nat 20 point in current slide pane group. Slide to Cauchy's integral formula. Slide to Cauchy. The value of a holomorphic function inside a region is completely determined by its values on the boundary of that region f of a equals 1 over denominator, 2 pi I n denominator, contour integral of f of c over denominator, z minus a n denominator, dz and an area expression.
Okay, so every participant can do that, and nobody else in the meeting knows. So they have this control to customize their experience with the slideshow as it's running, as the presenter is presenting it. So keep that in mind when you are presenting remotely to use PowerPoint Live rather than screen sharing. And then if you are exporting your presentation as PDF to share, make sure you use save, like the first item highlighted in green here, or export, the second item highlighted in green. Use one of those two options for doing your PDF export and not print, because when you use print, the PDF that you generate is not accessible. You want to follow the practices that Sarah and I talked about to make your PowerPoint accessible, and then use save or export, and then that accessibility in your presentation will carry over to the PDF that you create. And you might have save as Adobe PDF in your menu. That comes from an add-in that's not the built-in feature that I'm talking about today. And if you are exporting your PDF from PowerPoint or Word for the Mac, you'll have this best for electronic distribution and accessibility option, which is on by default. Make sure you use that option to create an accessible PDF. Here's an example of the PDF that was exported from Word, and I'm able to read it in Adobe Reader with the JAWS screen reader. JAWS provides this experience where you can navigate with left and right arrows, but then up and down arrows to drill into the parts of the expression.
Open x plus a, close to the n dash th equals sum from k equals 0 to n of n, choose kx to the k dash th times a raised to the n minus k power math content. Enter math content. Math viewer, equation navigation. To review the expression, use the arrow keys. Press insert plus h to list additional commands. Open x plus a, close to the n dash th equals sum from k equals 0 to n of n, choose kx to the k dash th times a raised to the n minus k power. In base x plus a. In superscript n. Out of superscript, open x plus a, close to the n dash th. Equals. Sum from k equals 0 to n of n, choose kx to the k dash th times a raised to the n minus k power. Sum from k equals 0 to n of n, choose kx to the k dash th times a raised to the n minus k power.
So that's an example of how you can navigate that math hierarchically in the PDF that's exported. And the way that is possible is that Word and PowerPoint export MathML for the math that the Adobe Reader and the screen readers such as JAWS and NVDA are able to navigate. I can show you real quick. In Acrobat Pro, you can see where we put in alt text for the equation automatically. It's the equation spelled out in words. And we also put the MathML there, which provides that rich experience that you saw with JAWS earlier. And NVDA can use that as well. Really good. Some of the improvements that I showed today are fairly recent. So if you are a Microsoft 365 subscriber and your build is up to date, you should have these improvements. If you are on semi-annual channel, it'll roll out to you a little bit later this year. And if you are on one of the older of what are called perpetual license versions of Office, you will not have some of the recent updates until you upgrade your product to a newer version. But have a look at which version you have. Give these a try if you use any of these apps. And there's a link to a blog post on this slide that has more information about this. And there's a second blog post that we published in February with more updates that I can share as well.
I put the new one in the chat.
Thank you so much.
Peter, we have a question in the chat, which I think Ailee can answer the first half and you can answer the second. This is impressive, but it seems quite jarring and difficult to understand. I'm curious what the experience of blind people is when interpreting that kind of speech. And then for you, in a sec, is there a continued effort to make that speech more articulate and human?
As a previous very visual learner, it is still sometimes jarring, especially when you're trying to figure out, like, in your head what that math equation is that it's reading to you. Because it's like, for instance, even for those that can see, just listen to one of those math equations and try to write it down. It is a little bit difficult. It takes some learning. But with me now, I can read it, but I do, like, not read it, but hear it and know what it's saying. By the way, that's what I mean. But I do wish sometimes it was a little bit more human, because I feel like it would be a little bit more easier to perceive what's going on.
That's the first part of our math accessibility workshops that we do. If you look at my list of resources, I did a couple workshops before we met Peter with my space systems faculty members, and we really talked about enunciation. And I talk with my hands, so I tend to make parentheses as I'm talking for the students who can see that, and just inflection, because math is a language. So, Peter, what do you know about robot voices?
Yeah, so it's an area of where it was ripe for innovation. And like in narrator, for example, we've made some improvements in natural voices and making them sound more human and having the sort of qualities that you're used to. And that's something that's going to continue to improve over time. As you can see, the experience for a screen reader user is not easy. And this is when there is good and accurate information. Imagine I didn't show videos of when it reads nothing or it reads the wrong stuff. Just imagine that. Definitely not something that people can work with. So yeah, it's not easy under any circumstances, but when you put accurate information that they can navigate properly, that is super empowering. It really unlocks a whole world of possibilities. Even if it has a learning curve to it, there's still a lot you can do with it.
And one thing I really appreciated with working with Jeffrey Kahn at Ohio State University with Taylor Swiftbot is that they were asking a blind person's perspective and to go through it. Not just, I have full vision, but I'm gonna pretend like I'm blind. But that's different because you can open your eyes or use them and see. I don't have that option. So it's like I can give you the real perspective and be like, I really just don't understand this. I still don't. And with time throughout him working with the software engineers and giving stuff back to me, I was able to understand it more. And it's really been, to me, very eye-opening, and pun, but no pun intended there, over the last year and a half, just how much things have advanced when it comes to screen readers and what I can now access, especially in the way of STEM. So while it sounds a little robotic, it's come a long way, and that means it's just going to continue to advance from here. I'm very excited of where it's going to go in the next couple years.
I know we're really short on time, and Sara wanted to close out a couple things. Peter, there was one question real quick about, are there plans to build read aloud functionality into PowerPoint similar to what it is in Word?
Oh, there's only a very limited ability to do that currently, but it's a good point you raise and something we'll take a look at doing. And Word does have some pretty nice support for that, and it works with the native Office math.
I'm going to jump back to my slides very quickly just to remind folks, we talk about visual science communication from many different perspectives every other week for 4 weeks in a row. Our very last session is 2 weeks exactly from this same time, thanks to the time change not happening. We have Sandra Bay and Takinora Fujiwara, who are both professors at the University of Arizona. They're going to be talking about communicating complex data through 3D representations, examples of planetarium visualizations, and data physicalization. We plan to be back in the fall talking visual science communication. We have maybe 1 more minute to bring up a question. There was the question of whether PowerPoint Live works only in Teams. Can you confirm yes or no that it works only in Teams?
It's only available in Teams. However, recently Microsoft has published an SDK that allows other apps to integrate it. In the future, yeah, I can imagine it being integrated in more applications.
Wonderful. And then one quick question from a student in our class. He was wondering whether STEM has the most difficulty with with accessibility in terms of education and applications, or are there other fields that have similar levels of accessibility deficits?
Also, like the arts, if you think of it that way, also has a lot of accessibility difficulties. But I will say that with STEM, especially, I could speak personally, had the most difficulty with professors. Just seeing that anything I were to go into work wise, if I were to do a STEM major, I would just be seen as a major liability, even if I was just working like in a cubicle. They're like, anything you did. And I'm just like, you would think with the ADA being created in 1990 that we would have come a long way, but we still have a long way to go when it comes for equal access and disabled individuals being seen as equal. It's like, yes, I couldn't do the nursing job I wanted to do. Yes, but there's plenty of nursing jobs I could still do while being visually impaired and blind.
And I think that's our big takeaway from today, that real people are impacted by this. That's why I love Peter and his team so much, because it's not just students, it's faculty, it's the workforce, the STEM workforce, and every other, because a lot of these updates aren't specific to equations and that. So it is truly making a difference on who gets to be in STEM or gets to get a degree or work in the field.
Absolutely.
Well, thank you. I have my shirt on. I was showing them before. It says progress over perfection. It's a phrase that one of my good friends and collaborators, Meryl Evans, who you can follow on LinkedIn, she is deaf. She reads lips. And we facilitated on Zoom many trainings. So I got to learn accessibility, facilitating with a person who is deaf. There's so much more to accessibility. You can always learn about it. There's always something more for you to learn and grow. You can find out about our speakers from the page where you registered. We have links to their social media where you can follow them and learn more. I don't know if you want to share your emails in the chat as well if people want to follow up. I know, Sarah, earlier when you were speaking, we had a request for references for some of the statistics that you were sharing as folks want to help in the process of getting the word out. And allies are very important. And like you said in the first quote, you may be an ally right now, but you could become part of the community of people who are disabled. 25% of society is that. And the older you get, the more likely you are to join that team. I do accessibility trainings and people, it is a lot more than what you'd realize, but we encourage you to continue to grow and learn about it. And I thank you all for spending your time today. Ailee, hope you have a most fabulous birthday. I almost was going to have some music that came on that was like, say it's your birthday. I didn't, so I just sang it for you instead.
Okay, thank you. Thank you.
And thank you all for joining us and being actively involved in the chat. We had a lot of great stuff in there. We put all sorts of resources in the chat, and you can always reach out to me, Kobilka at arizona.edu, and I'm more than happy to connect you with any of our wonderful speakers from today. So thank you, everyone. We hope you have a wonderful rest of this first day of spring.